Okay, we have here another interesting Laplace transform. I've got the Laplace transform of sine t over t. And now this is something I kind of did actually within an integral. I think this comes up when you integrate sine t over t from 0 to infinity. It's like really the same kind of thing. But I just wanted to do specifically a video on just this Laplace transform. The way I want to do this is we'll just use this formula over here to the right that's set up in exactly the right form, as we've got t in the denominator here, and it allows us to turn this into this integral here. In order to use that, first we need what's our f of t value in our problem. For f of t, we're just going to be looking at sine of t. In order to get this value over here, we're going to want a Laplace transform of this. I think the most confusing thing with this formula is just kind of notation and like the variable name changes. So how this works, if we're taking the Laplace transform of f of t, we usually denote this, we usually say our solution is going to be a function in terms of s, and we use the capital F for the solution of this. And then notice in our formula, they have this, the variable in it, it's just u. So we need to do a variable change. We're just going to change everything where we have s, we'll change to u, but then we're going to get the s back still, because the Laplace transform should give us still, it should give us a function in terms of s, so we get it back by putting the s in the bounds. So to start with on this, for our f of t, again being sine t, we just want to find the Laplace transform of sine t. We have our formula for this. This is going to be s squared plus the coefficient squared, which is just 1. So that's just going to be s squared plus 1. And then we get back, and then we're also going to have this coefficient in the numerator. So then over here, to use this formula, let's write the whole thing back. We want the Laplace of sine t over t. Then we have the integral from s to infinity. Do a variable change on this same expression, but we just want to change it to u. So we're going to have 1 over u squared plus 1 du. Go ahead and integrate on this. This is just going to be our arctan formula. So what we get is arctan of u evaluated from s to infinity. Plug everything in to evaluate. Arctan of infinity is going to be just pi over 2. Plug in an s, we get arctan of s, and that's it. It's a pretty interesting result. Not many of our Laplace transforms look this way, where we end up with a constant and we end up with arctan. So a really good problem, and this is kind of an alternative method when you have this as an integral, where you could do Feynman's trick or you could do this. It's really the same thing, but it's just kind of another way to do it. Anyway, there you go. Thanks everyone for watching. Have a good day.